Hello, I am Takao Maruyama, a Senior Research Fellow at the JICA Ogata Research Institute. In this video, I'd like to introduce you to evidence for the JICA sector strategy in education. This is a joint research with Professor Takashi Kurosaki, Hitotsubashi University, Japan. Worldwide, more than 380 million primary school-age children are not reaching the minimum proficiency level in mathematics. Most of those children are living in low or lower middle-income countries. For example, a large volume of primary second grade students in developing countries, including India, Uganda, and Nicaragua, still cannot solve simple two-digit subtraction. The advance in learning per year of schooling is also small in developing countries. Students who have difficulty mastering math content in early grades struggle to learn advanced content in the upper grades. To address challenges in achieving SDGs Goal 4 in low and middle-income countries, JICA has developed sector strategy in education, JICA Global Agenda, and cluster strategies. One of the four pillars in the sector strategy is the improving learning through the development of textbooks and learning materials. The evidence that I introduce you in this video is from El Salvador. El Salvador is a country situated in the region of Central America. While primary education grade 1 to 6 was compulsory in El Salvador, the net enrollment rate was around 85% in 2017. Around 7 to 8 students out of 10 reached the last grade of primary education. In the separate study, we conducted the math learning assessment for grade 1 students of lower secondary level in the country in 2018. After 6 years of primary education, students did not master the foundations of mathematics, including the 4 basic operations. For example, only 42% of the students could correctly answer the item 43 minus 17. Regarding the item 2 by 2 by 2, 34% of students confused multiplication with addition, answering 6. For the division item 612 divided by 102, half of the students did not write any response. The low level of math learning began in early grades. In this study, we conducted a baseline survey for primary second grade students at the beginning of the school year in 2018. The baseline test results indicate low levels of math learning. While approximately 80% of students correctly responded to a single-digit addition problem 1 plus 3, the percentage of students who could correctly answer a single-digit subtraction problem 5 minus 3 was approximately 25%. For an item that asked students to count 17 circles drawn on the test sheet, the correct response rate was approximately 50%. The traditional class style of mathematics in the country was that teachers explained how to solve math problems and posed example problems. Students listened to the explanation and took a note, but most of them had difficulty in solving the problems because of the low level of learning. Typically, students merely copied the answer without understanding how it was derived. Teachers do not pay attention to how much students learned and move to the next new topic. The research conducted by Bruce and Luke 2015 indicates that the situation is common in Latin American region. In El Salvador, the Ministry of Education developed a math textbook called ESMATE textbook with technical cooperation from JICA. In teaching and learning practices, textbooks are an important intermediate that links curriculum, teachers, and students, as they describe the content and methodology of teaching and learning. In the textbook developed in El Salvador, subject contents were carefully subdivided, and the contents were sequenced to assure small-step learning by students. The textbooks were designed to facilitate lessons in which students engage in learning, mainly through solving math problems. Each page of the textbook, which corresponds to one class, is structured along 4 steps of student math learning. 1. Present the theme of the lesson. 2. Pose example problems. 3. Explain the general principle. And 4. Provide exercises. The Ministry of Education in El Salvador developed teachers' guides and student workbooks corresponding to the textbook. The distribution of the teaching and learning materials were combined with other types of interventions in this slide at the ESMATE program. The ESMATE program was designed to increase the student engaged time in learning math. The student engaged time is the time spent in a lesson when students in a class were solving mathematical problems, referring to their notebook or textbook, or consulting with each other. This study investigated the impact of the ESMATE program using a randomized control trial, RCT. For the research, 250 basic education public schools were randomly sampled in the central and eastern part of the country. Half of the schools were randomly assigned to the treatment group, while the other half was assigned to the control group. To assess the math learning of students, the experiment continued for 2 years, and 3 rounds of surveys were conducted. The school year in El Salvador starts in mid-January and ends in mid-November. This study conducted a baseline survey from January to March 2018. The endline survey from September to October 2018, and the follow-up survey from September to October 2019. To account for the progress following the curriculum, test items differed across these 3 tests. The test administered during the baseline survey assessed math content learned in the first grade. The test given at endline survey assessed math content learned in the second grade. The test given for the follow-up survey assessed math content learned in the third grade. Based on the common math items in the test for endline and the follow-up surveys, the test scores were linked using the item response theory. The results of the endline survey shows the 1-year impact of the ESMATE program. In year 2 of the research, the control group also received the ESMATE program. If the impact persists in the year 2, it demonstrates the accumulated impact of the first-year interventions in the following year. Let us overview the results of the experiment. The average 1-year impact of the ESMATE program is estimated at around 0.49 standard deviations of the math scores. In year 2, after 2 years of exposure to the package, the impact is estimated at 0.13 standard deviations as compared to students in the control group who only received 1 year of exposure. Students in the treatment group advanced math learning in the year 2 of research based on the improved understanding in the previous year. To analyze the impact on student math learning from a different angle, we divide the test items of the endline and the follow-up surveys, respectively, according to the cognitive skills, that is, knowing, applying, and reasoning. The magnitude of the one-year impact of the ESMATE program is largest for the cognitive skill of knowing, followed by applying and then reasoning. Students in the treatment group could improve math learning with the textbook that assured small step learning, and the textbook also included math problems in various daily contexts and advanced problems. Students in the treatment group could develop their applying and reasoning skills through solving the math problems. While the accumulated impact of the ESMATE program in year 2 of the research is positive and statistically significant in the cognitive skill of knowing, the accumulated impacts on applying and reasoning are close to zero and not statistically significant. In addition to the student math assessment, this study conducted math lesson observations and interviews with teachers at the endline and the follow-up surveys. In year 1, the impact is positive in the aspect of walking around in a classroom to check student notebook and assigning homework. Conversely, in year 2, the difference in the percentage of teachers who walked around in the classroom became statistically insignificant, which indicates that the ESMATE program helped teachers in the control group catch up their teaching skills with the treatment group in year 2 of the research. Textbooks can play key roles in improving student math learning. Textbooks are used for making annual teaching plans by teachers, and they describe the content and methodology of teaching and learning. Textbooks are also used when students study at home. In this study, we investigated the impact of the ESMATE program that included the distribution of math textbooks that were carefully designed to improve math learning through 2-year-long experiment in El Salvador. The ESMATE program improved student math learning by 0.49 standard deviations of the math scores in year 1 of the research. In year 2, after 2 years of exposure to the package, the impact is estimated at 0.13 standard deviations as compared to students in the control group who only received 1 year of exposure. Students in the treatment group advanced math learning in the year 2 of the research based on the improved understanding in the previous year. While it is necessary to adapt the textbook and the other combined interventions, as each country has its own curriculum and instructional language, the ESMATE program shows how it is possible to improve the math learning outcomes. If you are interested in the program, please visit the URLs shown in this slide. Thank you.